This is the AP Physics FRQ. This is on the QQT. This is 2013's question number 3. The QQT will always have 12 points and the suggested time is 25 minutes. The QQT does have a lot of graphing and analysis as well as a derived part. Here you could read the scenario. The disk shows above spins about the axle as its center. A student's experiments reveal that while the disk is spinning, friction between the axle and the disk exerts a constant torque on the disk. Here they ask you to graph certain things here. I want you to make sure that you understand the words. All that is being asked here is to graph based on the equation that you come here. So it is the angular velocity as a function of time. And then here, this is the angular acceleration as a function of time. Until the disk comes to rest at t equals to t1, which is the end. Let's look at how it's supposed to be graded. Here the angular velocity does decrease because it has a initial angular velocity. Initial is positive, and then the final is 0 because it stops. The fact that this is going down, this has a negative slope, is the reason why the angular velocity has a negative value. And again, this is constant because this is a linear, and the slope of a linear will get you a constant value. All right, and here's the answer of how they grade it. Let's take a look at the graders here. So here the graders look like they gave the earn 2 points for the correct initial angular velocity. So they get a point here. And then they get the points that it is decreasing. So for the curve has an angular positive velocity. That's correct, and decreased to 0. So they got that point. For a curve that is a straight line with a negative slope showing the angular velocity approaches 0. So they got that point. For a curve that is negative for the entire time, did they get that one? Earns 1 point. So they get having the correct issue and decrease in time, but did not earn the 1 point because it's not a straight line. Ooh, it did say straight. This here, it curves. So they did not get this one. This is a 0. Then they get the curve is negative the entire time. This shows it's negative, but that has to be constant. But they didn't get that one. Okay, it's very easy to grade because it's just graph. All right. Then here, let's see what the grader said here. They should earn the first 2 points because it is decreasing and it is linear because it is a straight line. Lastly, it says cancel must be. Oh, that's a parenthesis. Acceleration must be constant. They even wrote it here. And 1 point for it being negative and 1 point for it being a non-zero constant. Yeah, so they earn both points here, 2 from the top and 2 from the bottom. That's the correct graph. Okay, the QQT is very easy when it's graphed like that. Next, they ask you to drive this equation for the rotational inertia, and they just make sure it is only in terms of torque, angular velocity, omega, and any physical constant. I want you to understand what derive means. Derive means that you have to start with an equation on the formula sheet and solve it using the algebra. So in the end, you better just have an I equaling to something here. Let's take a look at how it's answered here. First, for using an equation for the rotational version of Newton's second law. So it's probably Newton's second law is F equals to ma. So they're probably asking to use torque is equal to rotational inertia times alpha. They're probably asking for that version. Okay, for an appropriate rotational kinematics equation. So this is to solve for the angular acceleration, and that should be in the end. So they have to use this substitution somewhere here. Then in the end, that's the correct answer. So it looks like this is worth 3 points here, right? Note that a point is still earned if there is a minus sign because the minus sign just indicates a direction. So this is how it should probably look like. A alternative solution is using angular momentum with rotational impulse. That's interesting. All right, so let's see how the graders grade here. So this person uses a kinematics equation. Then they have a that's the correct angular acceleration. They start here, then they got here. Interesting. So the grader said that this earned 2 out of 3. 1 point is using the rotational version of Newton's second law. It's this. This looks like this is the m is equal to F equals to A, which is found on the formula sheet. This is on the formula sheet. Okay. So that's how they earn the first point. And then they substitute it. The response did not earn 1 point for the correct answer because this was never substituted. So that's not here. This should be not. So they did not earn that. They did not earn that. That's 0. And they did earn 1 point for using the rotational kinematics equation, which is this, which gets them this, which matches with the second criteria right here for using the appropriate kinematics equation. All right, what about this version? So this one looks like they used the angular impulse one. All right, here it gets them all points. This version on top here looks like this is the F is equal to ma. No, that's not the F equals to ma. This looks like it's the oh, they used the impulse version. So this what they wrote here is the angular momentum L. That's the angular momentum. Then they set that to the other angular momentum. This is the final angular momentum. And the reason why they do that is because initially it says that the change in the angular momentum equals to 0. This means that the rotational impulse was equal to 0. Okay. Interesting. That's an interesting way of doing it. All right. So here they earn all points, complete points for how they're deriving it. And again, notice they just come straight from the original equation coming straight down with the right substitution. In the end, they had I. Okay, you just have to do some algebra here. So good. All right. Then next, it does ask you to keep sketching. And the way the second part always works here, the C, is that something changes in the scenario. Sometimes mass is introduced or friction is introduced, or sometimes friction is reduced. In this case, in this experiment, the disk again has initial positive angular velocity. And then at t equals to 1/2 t, which is in the middle, the student starts dripping oil on the contact surface between the axle and the disc to reduce friction. So here it reduces friction. As time passes, more and more oil reaches the contact surface, reducing the friction even further. So other questions, you introduce friction. In this one, you reduce friction. Let's see how that affects the graph. All right. So that's the answer. It says for a curve with a clear change in the slope of the curvature at 1/2, and it shows a decrease in the speed afterwards. So this is, let's say this has a slope of -5. I'm just making up some numbers, right? Rads per second. This one here should be like -4 rads per second. The reason why is because there's more oil, so that the angular velocity is decreasing less. Okay. And then here, it looks like it increases. So this is constant. And then it goes up a bit. The reason why it goes up a bit is because this indicates the change in the angular velocity. All right, that's why it spikes up, because technically this here is a curve. All right, let's see how the graders see. So this person drew a concavity, and then angular acceleration is completely positive. Wow, okay, that does not even make sense. So here, this person does get 1 out of 3 points for showing a clear change in the slope of the curvature. So after t equals to 1, so that's the change part that they got the 1 point from, even though this graph is completely wrong. The graph did not, and yeah, that's it, did not earn anything else. The graph of the angular acceleration earns no points because it indicates an increasing magnitude between 1/2 and 1/10. Okay, so yeah, it does not, it only earns 1 point here. All right. What about this one? So this one's a complete answer. This matches it identical. So that's all the points. So lastly, after the QQT part, we'll have a scenario like this that changes the graph. Then in the end, the QQT will have sort of like an explain part. Here, the student is trying to match mathematical models to the magnitude, and they write down two equations. Which equation better mathematically models this experiment? Equation 1 or equation 2? Briefly explain. And here's the point distribution for it. So notice that the correct answer is equation 2, but if the wrong section is made, the explanation is not graded. All right? So you have to select the correct equation for it to be graded. All right. So here it says equation 2. So now they can still grade it. And here it says that no points were earned because although they checked it correctly, there's no mention of whether the torque or the magnitude increases or decrease in either equation. Let's see what the student wrote. T plus 1/2 t is the time that the torque applies on the disc for when the oil is presented after 1/2 t seconds, which is the point that they start applying the oil. The first equation shows t minus 1/2 t, which is 1/2 t before the real time. That was when they did not apply the oil. Yeah, that doesn't explain. That does not explain why that would be better. Okay. Okay. Notice that the way this is answered is mostly something increases, right? Right. The explanation here is torque decreases because it's probably on the bottom of the fraction. So let's look at the answer here. This answer, this does earn 1 point for selecting equation 2 and indicating that the torque does decrease as time increases beyond 1/2. So torque is the relevant. Looking back at the answer, it would be right here. Time would be in the denominator, and since everything else is constant, that would be in the applied. Goes to 1/2. The torque decreases. This was exactly be possible. Yes. So that's what was correct. He knew that where is it? That it would be in the denominator, and that's what causes the torque to decrease. So that's how he earned that point there. All right. So that's about it. But this is how a typical QQT is being graded. Right? There's a graph, a derived, and other graph like the scenario changes. Then there's an explanation. Okay. In the explanation, it says briefly explain. So it's probably short answer, but make sure you use the strategy of it's in the bottom of the denominator or on top of the denominator. There you go. This is what a QQT question looks like.